For those of you that are new to geochemistry, we want to show you that there is more to just going out, taking samples, sending them to the laboratory, and then just looking for the high numbers. And it's always important to take a much broader approach. And I have a brief amount of time to give you one illustration of this, and this is something that happened to me very recently, actually, is I was doing some mapping in the Bangamols, which is in the central part of Western Australia, and I took it upon myself to start taking rock samples of manganese sediments, which are very common in that part of the world. They look like that, or like that. And I took these samples, I took 11, sent them off to a laboratory, and when they came back, I looked at the manganese values. My interest in manganese was not as a manganese deposit, but as manganese as a method of scavenging base metals. And when I got the results, you will see here that 5 of the 11 samples went below detection. And I can point out that detection was actually much lower than 5 ppm. Now, it is almost impossible to take a rock anywhere in the Proterozoic or the Archean, a sediment anyway, and for it to come back with such low manganese values. Anyway, I phoned up the laboratory and asked them some questions, and they chose to redo the analyses, which they did. And you can see here that those that went below detection limit were now substantially over that value. In fact, they were over range. And one thing I should also point out, even the laboratory's in-house check sample in the original analyses on the left, when it came back, it was a substantially different figure. The check was very different from the original analysis. Anyway, the re-analyses went over range. They were reanalyzed, and as you see on the right of the table, some of them were extremely high. Now, when I queried this with the laboratory, they said, well, our in-house QA/QC system defaulted over-range samples to 0. And if, in most cases, with rock chip samples, I mean, manganese is not an element that's going to pose any problems to you for a laboratory. It's pretty straightforward. I'm probably going to be inundated with the laboratories present here saying, no, that's not actually the case. But mostly it is. It's rarely near detection limit. It's always fairly high. And the point I want to make about this is that this illustrates that everybody who takes samples and looks at the results must be diligent and take a critical eye of what's going on. It's not something that you can just leave to your IT people to say, well, statistically they look fine, because geologically they're not fine.